to that end, I was thinking I would review this article about web components because it kind of ties into HTMX. The whole point behind HTMX is simplification, where, well, that's one of the points. Let me put it that way. Um, it's a simpler framework that does not have a lot of baggage with it. If you compare it to something like React or Angular or Vue or any of the other go-to frameworks that people tend to use for front-end work, HTMX can get you a lot of the way there with a lot less baggage. You just have to change your mindset as to how front end works when you're working with HTMX. That kind of leans into my programming philosophy, which is use stuff that's simple and doesn't require a lot of overhead, if any. My favorite build processes are no build processes. If you can get a no build process and you can satisfy any business needs that you need to meet, whether it's on a personal project or otherwise, to me that's chef's kiss. So to that end, I think web components kind of lean in that direction because web components are um, baked into browsers and they have um, general availability across most browser platforms. So if you're going to use a web component, you're kind of close to the metal, so to speak. So I just wanted to see what this article was like and what it had to offer. So let's get into it. Um, okay, November 27th. So actually, this was from yesterday. Seen a lot of great posts about web components lately. Many have focused on the HTML web component pattern, which eschews shadow DOM in favor of progressively enhancing existing markup. There's also been discussion, including this post by yours truly. Oh, I remember this one. Web components will outlive your JavaScript framework. I think Primogen did a review on this. I could be wrong. About fully replacing JavaScript frameworks with web components. Those aren't the only options, though. You can use web components in tandem with JavaScript frameworks. So to that end, I want to talk about a key benefit that I haven't mentioned. Web components can dramatically loosen the coupling of JavaScript frameworks. I already generally agree with this. To prove it, we're going to do something kind of crazy. I like it. Build an app where every single component is written with a different framework. That's almost too crazy. You have to be a particular kind of crazy to do this. It probably goes without saying you should not build a real app like this. Yeah, of course. But there are valid reasons for mixing frameworks. Maybe you're gradually migrating from React to Vue. Maybe your app is built with Solid, but you want to use a third-party library that only exists as an Angular component. Maybe you want to use Svelte for a few islands of interactivity in an otherwise static website. Okay, that's pretty good. I think this kind of thinking is right tool for the job kind of thinking, which I agree with. And sometimes you have to mix and match the tools that you're using. So instead of just leaning to, well, I'm just going to do, we're going to do everything in React, for example. It doesn't matter what it is. If it's on the front end, it's React. Sometimes you do want to mix different tools so that you can get the best, the best output for what it is you're after. So it's actually not as crazy as it sounds. So here's what we're going to create. Simple little to-do app based loosely on to-do MVC, which apparently Backbone, Ember, Angular. Is Backbone still around? Is Ember still around? Anyways, okay. So there's a to-do. I think this is an actual functional demo. Yeah. You can all right, okay. As we build it, we'll see how web components can encapsulate JavaScript frameworks, allowing us to use them without imposing broader constraints on the rest of the application. Okay. What's a web component? In case you're not familiar, here's a primer on how they work. We declare a subclass of HTML element in JavaScript. Let's call it my component. And yes, this is pretty typical. You have to use your shadow DOM, which is open, but you can close it for particular reasons. And then your inner HTML with some styling. Okay. That call to attach shadow in the constructor makes our component use the shadow DOM, which encapsulates the markup and styles inside our component from the rest of the page. Connected callback is called when the web component is actually connected to the DOM tree, rendering the HTML contents into the component's shadow root. So you can kind of think of the connected callback as like an event, almost like when this component is triggered and activated in your HTML, connected callback is like an event that you can listen to that says, yeah, I'm here. And then what you're doing is you can think of the shadow DOM, in case you don't know what it is, you can think of the shadow DOM as like an external black box that does not have an impact on the rendering of the page until the element becomes active. This foreshadows how we'll make our frameworks work with web components. We normally attach frameworks to a DOM element and let the framework take over all descendants of that element. So if you've seen a React app, you're going to have a parent element and you're going to say, React begin to do X, whatever it is you're set to do on this element. And then React just controls that element. With web components, we can attach the framework to the shadow root, which ensures that it can only access the component's shadow tree. Next, we define a custom element for my component class. So this will end up being, yes, exactly. Whenever a tag with that custom element name appears on the page, the corresponding DOM node is actually an instance of my component. So, right, this is exactly how you create a custom tag. So it's like any other HTML tag. And the point is, here, I didn't even make myself smaller. The point is that you're going to, this tag is going to instantiate a class of whatever your web component is. So if you remember the connected callback up here, calling this in your HTML DOM tree is going to trigger this connected callback. Okay, so yeah, I think this is actually, yep, there it is. So you can actually see, like, he put it on this, like on this page, which is great. You can see my component, and you can see the shadow root, which is the shadow DOM, and you can see the inner HTML along with the style, and it's all here encapsulated in this guy. Okay, scaffolding layout. The entry point of our app will be a React component. Here's our humble start. So let me make sure. I'm gonna squeeze my head more. Okay. There. Okay. Here. So we've got a to-do app JSX file. Okay. We could start adding elements here to block out the basic DOM structure, but I want to write another component for that to show how we can nest web components in the same way we nest framework components. Most frameworks support composition via nesting like normal HTML elements. From the outside, it usually looks like this. On the inside, there are a few ways that frameworks handle this. For example, React and Solid give you access to those children as a special children prop. Right. So you can, if you're paying attention to how this was done, okay, and how the custom tag was done, you can actually kind of already tell how you're going to mix this in with React. You can already see it. But let's keep going. With web components that use Shadow DOM, we can do the same thing using the slot element. When the browser encounters a slot, it replaces it with the children of the web component. Slot is actually more powerful than React or Solid's children. If we give each slot a name attribute, a web component can have multiple slots, and we can determine where each nested element goes by giving it a slot attribute matching the slot's name. Okay, let's see what this looks like in practice. Here it is using Solid. So you've got a layout, wrapper, header, title, filters, to-dos, input. Here's your layout element. So that's going to be your tag. And then here you go. It's going to render to-do layout, which is really just this guy. There are two parts to a solid web component, the web component wrapper at the top and the actual solid component at the bottom. The most important thing to notice about the solid component is that we're using named slots instead of the children prop. Whereas children is handled by solid and would only let us nest other solid components, slots are handled by the browser itself and will let us nest any HTML element, including web components written with other frameworks. So you can see the slots here, to-dos, input. Right? So naming these slots gives you a way to choose where to inject other elements that you might be borrowing from, other frameworks or whatever. Where were we here? The web component wrapper is pretty similar to the example above. It creates a shadow root in the constructor and then renders a solid component into the connected callback method. Note that this is not a complete implementation of the web component wrapper. There is a lot more to web components, yes. At the very least, we'd probably want to define an attribute changed callback method so we can re-render the solid component when the attribute changes. If you're using this in production, you should probably use a package Solid provides called Solid Element that handles all this for you. Okay, now here's what I don't like about this tutorial. It's kind of jumped. So we started out talking about like web components and using Solid and React, and it kept things simple. But I think now it's kind of jumped into assuming that you have an understanding of these frameworks. And if you don't, this might be hard to follow. So I get why, because the point is to show that you can mix and match these things and how it works together. But there's a jump here that's not being filled in. There's a gap that's not being filled in. In any case, the point of the attribute change callback is so that you can add custom attributes to these web components, like say this guy, and when an attribute changes, you're going to do something about it. So an attribute would be something like the style tag or the class tag, or other kinds of, like here. This aside, the ID, the class, the style, those are attributes. So if you're going to make a change to one of these attributes, what you're saying down here is that you're going to want to re-render. Say, you want to render the new value of the attribute. So that's the point of it. So now in the React app, we can use our to-do layout component. So here it is. So your to-do app is wrapped, and then you're going to call in the custom component web component you've created, and then note the slot, right? So this is where the slot comes in. So what's going to happen is this guy should end up in here. That's what should happen if it's done right. So note that we don't need to import anything from to-do layout JSX. We just use the custom element tag that we've defined. Okay, now here's the question. Can we see exactly how? Okay, so the to-do demo is a tag. The to-do layout is also a tag. And there it is. Okay, perfect. And you know what's nice though with the Chrome Inspector tools that they've made some updates. So like you can go through the shadow tree and you can actually like pick out the slot here and what's being put in it, which is cool. That's great. It even tells you the slot. Like it tells you that this is a slot filler. Very cool. Okay, so you get the point. If there was anything in filters, it'd be in there, whatever. But yeah, this guy is showing up here like this. That's a React component rendering a solid component, which takes a nested React element as a child. So in this whole example, the whole point was that solid kind of takes the place of a web component that you might write by hand. And see, it's solid element, web components wrapper for solid. So it's a way to write web components using the solid framework. You can do this all by hand too. Like web components are available. So adding to-dos. For the to-do input, we'll peel the onion back a bit further and write it with no framework at all. Okay, isn't that what I was just talking about? I think it was. To-do input. So you're going to define your input tag, yes, and here's your element. It's going to have a form. It's going to have a text input. And then you're going to add an event listener to the form. And it's going to be the submit. And you're going to take the form data and you're going to ship off an event. And you're going to pass the value. It looks like you're going to pass the value of the input as part of the event details. And then you're going to reset the form. I'm pretty sure. Between this, the example web component, and our solid layout, you're probably noticing a pattern. Attach a shadow root, render some HTML. Whether we handwrite the HTML or use a framework, the process is roughly the same. True. Here we're using a custom event to communicate with the parent component. That's the dispatch event, which is just new custom event. When the form is submitted, we dispatch an add event with the input text. So that's naming it. So you can go, now you could go like, if you grab the element, the to-do input, then you could go add event listener, add, and then you'd get the detail. The detail would come into you as an object. Event queues are often used to decouple communication between components of a software system. Browsers lean heavily on events, and custom events in particular are an important tool in the web component toolbox, especially because the custom element acts as a natural event bus that can be accessed from outside the web component. Before we can continue adding components, we need to figure out how to handle our state. For now, we'll just keep it in our React to-do app component. Although we'll eventually outgrow useState, it's a perfect place to start. Each to-do will have three properties: ID, text, string describing it, and a done indicating whether it's been completed. Okay. Use callback, use state from React. Okay, so now we're back in React land. Hang on one sec. Okay. So here's an ID, our to-do app. Okay, we're going to use state for our tracking our to-dos. We've added one. It's going to get a new ID, which is just auto-incremented. It's going to get a text for like what it is, title, and then whether it's done or not. Okay. We're going to listen to add. So here's our, yeah, perfect. Exactly what I was saying. Add event listener, add is really just this right here. And then our layout, our return JSX, is the web component layout with the title, the to-do title in the slot, and then our web component input. We'll keep an array of our to-dos in React state. When we add a to-do, we'll add it to the array. The one awkward part is that the input is the input ref function. Hang on. The one awkward part of this is that input ref function. Okay. Our to-do input emits a custom add event when the form is submitted. Yeah. Usually with React, we'd attach event listeners using props like onClick, but that only works for events that React already knows about. We need to listen for add events directly. So that's why you have the input ref. Okay, because you're going to listen to that guy. In React land, we use refs to directly interact with the DOM. We most commonly use them with the useRef hook, but that's not the only way. The ref prop is actually just a function that gets called with the DOM node. Rather than passing a ref return from the useRef hook to that prop, we can instead pass a function that attaches the event listener to the DOM node directly. You might be wondering why we have to wrap the function and use callback. The answer lies in the legacy React docs on refs, and as far as I can tell, has not been brought over to the new docs. If the ref callback is defined as an inline function, it will get called twice during updates, first with null and then again with the DOM element. This is because a new instance of the function is created with each render. So React needs to clear the old ref and set up the new one. You can avoid this by defining the ref callback as a bound method on the class, but note that it shouldn't matter in most cases. This is one of the problems I have with React, among many. You need to know a lot of these things under the hood, and if you don't, you can easily get caught in an awkward situation where, like this is rendering twice and you don't know why, and it's not in the new docs, but it is in the old docs. Anyways, in this case it does matter, since we don't want to attach the event listener again on every render, because that would be, at the very least, it would be memory consuming. There's no guarantee the garbage collector would remove the event listener. So we wrap it and use callback to ensure that we pass the same instance of the function every time. So again, yeah, so this is like a live demo. Now I'm not sure if it's just incomplete here and that's why my entries are not showing up, but you can see a lot of what is being talked about. Like, here's your input, right? And it's a form. And there's your input form field. Okay, to-do items. So far we can add to-dos, but not see them. Ha, there we go. The next step is writing a component to show each to-do item. We'll write that component with Svelte. Svelte supports custom elements out of the box. Rather than continuing to show the same web component wrapper boilerplate every time, we'll just use that feature. Custom elements for Svelte. Okay, so the code. So we've got a custom element we're going to call to-do item. So it's going to be the individual item we're adding. The attributes, ID, text, and done. An event dispatcher, which includes check. So guess what that's going to be for? A checkbox. And there it is. And so then you bind the checked event listener. You have a label. You have some area. On click, dispatch, delete. Okay, so there's another one. So we've got another event for delete. So you've got check, you've got delete, and then you've got an icon. Okay, so with Svelte, the script tag isn't literally rendered to the DOM. Instead, that code runs when the component is instantiated. The script tag isn't literally rendered. I see. Okay, yeah. So this does not go into the DOM. Our Svelte component takes 3 props, ID, text, and done. It also creates a custom event dispatcher, which can dispatch events on the custom element. The $2 syntax declares a reactive block. It means that whenever the value of ID or done changes, it will dispatch a check event with the new values. ID probably won't change. So what this means in practice is that it'll dispatch a check event whenever we check or uncheck the to-do, okay? Back in our React component, we loop over our to-dos and use our new to-do item component. We also need a couple more utility functions to remove and check to-dos, and another ref callback to attach the event listeners to each to-do item. So I guess now we're going to try and marry what's been done with, hopefully that wasn't too loud, I just tapped the mic. We're going to try and marry what's been done with Svelte here and web components with React. So we've seen a lot of the code. We have an add to do, we have a remove to do. So that's just going to remove it based on ID. We have a check to do, which is going to trigger its done state. Yeah. So we're just using a map and we just iterate over it till we find the ID and set its done state. The add event is still there. So we're doing the same thing here with React, another callback use callback so that we don't do this every time it's rendered. And we have a check and then a delete. And you can see that the details are passed along with it. And then what happens is as you build your to-dos array in your in this state, in the React state, you're going to iterate over them, and you're going to render out a to-do item web component done in Svelte. React Svelte. Now the list actually shows all our to-dos, and when we add a new to-do, it shows up on the list. Yep. Okay, filtering tools. The last feature to add is the ability to filter to-dos. Before we can add that though, we need a bit of refactoring. I want to show another way that web components can communicate with each other using a shared store. Many of the frameworks we're using have their own store implementations, but we need a store that we can use with all of them. For that reason, we'll use a library called nano stores. First, we'll make a new file called store.js with our to-do state rewritten using nano stores. So you've got a storage thing here, and you're going to go through all your to-dos. You're going to see which ones are done, which ones are left. You're going to have an add, a check, and a remove. And then you're going to filter, which I presume is going to get flushed out here. Core logic is the same. Most of the changes are porting from use state to nano. We did add 2 new computed stores, done and left, which are derived from to-dos and return completed and incomplete, respectively. We also have filter, which will hold the current filter value. I see. Okay. So now we go with view. All right. Bring in your nano store, bring in your store, initialize them, and then you're going to, right, with view you have to ship a template. I think that's pretty standard. And then you're going to demonstrate what the number of items in the store. Syntax pretty similar to Svelte. The script is run when the component is instantiated, and the template tag contains the markup. Vue doesn't make compiling a component to a custom element quite as simple as Svelte does. We need to create another file, import the Vue component, and call define custom element. We need to create another file, import the component, import from Vue, to-do filters, and then we define, I see, okay. Right. So you're importing it, and then you're defining your custom element as to-do filters. Back in React land, we'll refactor our component to use nano stores rather than use state and bring in the to-do filters component. So there we go. We're pulling in the store. We're grabbing the store individual items. We're initializing them. We're determining which ones are visible and not. That's what the ones that are visible and the ones that aren't. And then we iterate over them and show them. And here we have our to-do filters slot. So that's going to go in the remaining slot that we go if we go all the way back up here. Right here under title, right? So it's going to end up there. We did it. Now we have a fully functional to-do app written with 4 different frameworks, React, Solid, Svelte, and Vue, plus a component written in vanilla JavaScript. And then if I go like this, if I trigger something to be done, and yeah, there we go. And you can see now how those 3 stores, the done, to-dos, done, left, are just filters, right? They're just filters. Moving forward. The point of this article is not to convince you that this is a good way to write web apps. It's to show that there are ways to build a web app other than writing the entire thing with a single JavaScript framework. And furthermore, web components make it significantly easier to do that. You can progressively enhance static HTML. You can build rich interactive JavaScript islands that naturally communicate with hypermedia libraries like HTMX, which I am the lead CEO of. So I definitely did not pay this person for this article. Yeah. And I definitely didn't pay a lot of money for this article as CEO of HTMX. You can even wrap a web component around a framework component and use it with any other framework. Web components drastically loosen the coupling of JavaScript frameworks by providing a common interface that all frameworks can use. From a consumer's point of view, web components are just HTML tags. Doesn't matter what goes on under the hood. And then there's a sandbox and a reading list. Okay, that was pretty good. That was pretty good. So I agree with a lot of this. I do wish that there was maybe just a little bit more time spent on bridging the gap between the different frameworks. But I kind of also get it. Like, you can go look it up yourself. I just feel like maybe just a little bit more information about how and why. Like that part right here with React, and why he had to do the use callback function the way he did in order to attach an event listener. That's really good. That's a good way to like help bridge the information gap on the frameworks. So, if you're going to go into a tutorial like this and you're going to say, I'm going to go crazy and use a bunch of frameworks, which I think is great, maybe just a little bit more information for the readers on the how and why. But honestly, not not terrible. Um, it's just kind of a jump that you have to get through in your head. The rest of it was great. I like that he called out HTMX. I like that he said a lot of the things that I was saying at the beginning. I did not pre-read this, and I agree. Generally speaking, I agree with this. We tend to reach out for frameworks as some kind of multi-solution thing, and by default, we don't consider the other options. You can see taking like half an hour to an hour just to kind of like scope out different options might give you some advantages and open some doors that you wouldn't have otherwise considered if you had just gone with React to begin with. I think, just my opinion, I think web components and libraries like HTMX are going to show through proof that some of the frameworks that have led to the insanity that is front end web development these days, and I do think it's insanity, they're going to show through their use and prove themselves to be worthy of default consideration. Frameworks like React or Svelte or Vue, etc., have their place, but I think they become default too often. And there are plenty of other options. Some of them are a lot better. So this is good stuff. I hope the articles and libraries like HTMX and HTMX get more uh, shout outs because it's good stuff.